Hello, guys.
Hello, Professor.
Probably everyone is completely tired at the end of the week, right?
Yes.
Okay. Let me open the textbook. I would like to tell you that I received your tests, but unfortunately, not every student whose names I actually saw on the screen submitted their tests results. I mean test solution. And I really, again, like to get an email from that people with the explanation why they send me their tests. But it is just actually one or two people, but all other people, please be a little bit patient. I am in process of grading your tests, and according to my plans, I will be definitely working tomorrow, hopefully not on Sunday, but maybe on Sunday as well. But I am planning to send you your grades as I did with another quiz, which we took in the same manner, sending everyone a reply to your test, which you send me, sending you your grade for this particular test. Do you understand how I will be doing that?
Yes.
Okay. Another thing what I like to ask you is definitely, according to what I did before, this is my tradition, and I also have full solutions and allocation of grades for every single problem. And if you wish, I can start my today's meeting with you, releasing that information about weight of every single problem in this test. And I can show complete solutions. You can take notes and compare with what was sent to me. Do you want to discuss all these details about yesterday's test?
Yes, please.
Okay. In this case, I will be showing this also on the screen as I did before teaching my lectures. Please, first, grab a piece of paper or do that in your notebook. And these are on the top of this paper. All problems are listed and how many points we have in total for this test. This is again for test number 3 about trigonometry, and this is allocation of all these grades. I really recommend you to write this information down. Did you?
Yes.
Guys, try to reply in timely manner. Yes. So this was problem number 1. Simplify the expression. And it was a trigonometric expression where you had to use algebra and trigonometry to solve this problem. Cosine squared times 1 minus tangent squared. You can see here, I replaced tangent squared by sine squared over cosine squared, simplified expression in parentheses, which helped me to cancel cosine squares. So, and I was left with cosine squared theta minus sine squared theta, which is one of formulas for cosine of double angle, which means it will be cosine of 2 theta. Do you have questions about this problem number 1?
No.
In problem number 2 here, I am showing 2 different methods. I did not have here enough space. This is why I provided first method here, and the second method is demonstrated here on the side of that paper. Let's start with problem number 1 or 2, method number 1. What do we have here? You can look actually at your tests also if you did your work on the piece of paper. Cosine of 2 theta plus cosine of theta equals to 0. It is an equation, and we need to have the answer mentioning only angles which belong to the semi-closed interval from 0 to 2 pi. And here I'm providing first method right here. This is that equation. What did I do here? Your left side of equation is cosine of 2 theta plus cosine theta, and I used trigonometric formula of cosine alpha plus cosine beta, treating alpha 2 theta like alpha and theta like beta. This is the formula. There are 4 formulas. We usually call them here replacing sum or difference of trigonometric functions into products. And as a result of application of that formula, I got a product. And it was 2 cosine of 3 theta over 2, which you can see here on the third line, times cosine of theta over 2 equals to 0. After which I applied zero factor property and broke this into 2 separate pieces, part A and part B. In the first place, you can see cosine 3 theta over 2 equals to 0. And I solved that equation for theta. And second part B, cosine of half of theta equal to 0. And I solved that for theta. But what I got here, you can see K belongs to Z. Basically, I found all solutions from which I have to choose that solutions which belong to declared interval from 0 to 2 pi. This why, after that, I started playing with K values, first starting with K equal to 0, and I got from first family theta 1, from the second family theta 2 answers. After that, I plugged into that formulas K equal to 1, and I got another pair. But in this case, you got theta 3 and theta 4, but theta 4 could not be used as an answer because here I'm getting pi plus 2 pi, which is 3 pi, and it is out of declared interval. You can see I wrote this on the side that it does not belong to 0 to pi interval. So this why in the next step, I used only a formula from part A, general solution. This why you can see for K equal to 2, I have only one angle, theta 5, which also is good enough because it is 5 pi over 3. 5 pi over 3 is equivalent of 300 degrees. So it is definitely in our interval. And after that, I continued with K3, and I got another angle, theta 6, which is 7 pi over 3, but 7 pi over 3 is out of that interval. This is why I'm saying that it does not belong to this interval, so it is not our solution for this particular problem. So practically, in the solution set, you can see only 3 angles out of all possible angles, which will be solutions for equation, but there will be not only from declared interval. We need to choose only that solutions which belong to this interval. And this what we have on the bottom, pi over 3, pi, 5 pi over 3. Did you have an opportunity to write this solution down?
Yes.
Just one person? One more time. Can I move to the second method?
Yeah.
Second method. Second method is completely different. Here, you can see application of different formulas. Here, cosine of 2 theta was replaced by 2 cosine squared theta minus 1. This is another formula for cosine of double angle. Cosine of double angle has 3 different formulas. Why did I choose that particular one? Because it contained only cosines. Yes, definitely cosine in the second power. Why? Because in the problem, I already had cosine theta. In this case, I am getting a quadratic equation with respect to cosine theta. You can solve this as a quadratic equation. Even you could, let's say, replace cosine theta by another letter, let's say x, and in this case, equation will be 2x squared plus x minus 1 equal to 0. You can solve it for x, and after that, come back to, let's say, your cosine theta and continue. And solving this quadratic equation, you can use many different methods: quadratic formula, completing the square, complete square method, factorization, and etc. Here I'm using factorization. And this, you can see, you have parenthesis cosine theta plus 1 times another parenthesis 2 cosine theta minus 1 equal to 0. Let me write down this also. In this part, we have A. I really apologize. Just 1 second, please. I will write it down. A and B part also. This is the only addition which I had. And here I again apply zero factor property, splitting this into cosine theta equal to -1 in part A, and in part B, cosine theta equal to +1/2. And I can sketch another small circle for part A if you like, because I did not show that here. Just 1 second. I will show that circle, and I will show the point where cosine is equal to -1, excuse me, and this is that angle pi. This y theta 1 equal to pi. In the part B, you can see already that circle. Cosine is affiliated with 1/2. This y, I did not have enough space. This y, this circle is a little bit small. So you need to find on the radius, horizontal radius from 0 to +1, you need to find the midpoint. It will be your 1/2, and sketch perpendicular reaching your circles. Circle sides, and after that connect with the center, and you are getting 2 different angles. You can see actually in the solution set we have absolutely same angles as we had in first method, but it is absolutely different method. We treat our trigonometric equation after we apply trigonometric formula to replace cosine of 2 theta by what we have in the formula for cosine of double angle. We can get quadratic equation with respect to cosine theta and solve it first like quadratic equation, and after that solve 2 short trigonometric equation to get the answer. Did you have an opportunity to write this down as well?
Yes. Yeah. Yeah.
Okay. Uh, Problem number 3, the last problem on page number 1. Y equals sine parenthesis 2x minus parenthesis pi over 2 plus 2. What did I do here right away? I factored out 2 because it is right after sine of trigonometric function sine. And in parentheses right now inside, instead of 2x minus pi over 2, I have x minus pi over 4. And I started actually listing that properties. First is domain. Domain is set R, or all members of sine families have domains equal to R. Amplitude is 3. Sine is the family of functions which has amplitudes. This is why I'm first here also looking for amplitude. Amplitude is equal to absolute value of 3, which is 3. Period. That 2, which is in front of that most inside parenthesis, is responsible for the period. So this is omega. Actually, let me, I actually wrote it because omega, okay, period is equal to 2 pi over 2 equal to pi, because amplitude is, period depends on that omega value. Omega is equal to 2. We have here a horizontal shift. It is pi over 4 units to the right, or if you like, positive pi over 4. We have here a vertical shift also. And now at the bottom, you can see the information about the range of that function. I even showed details how we came to this conclusion about the range, because we had here a vertical shift, and because amplitude was equal to 3, you can see details of that calculation for this range. Finally, that range is closed interval, or we can say segment, from -1 to 5. What do you see here on this graph? You probably, I hope you can see, I tried to use different colors. The red dashed graph is y equals to 3 sine of 2x. This is the cousin for our given function, and they will have many good same properties. And finally, you can see it was shifted pi over 4 units to the right and 2 units up. And doing that, we actually got our graph of our desired function. You can see all points are labeled, and this, again, red color is our y equal to sine of 2x graph, and that dark solid graph is the graph of the given function, which we had in our problem number 3. This is what we should have.
I have a question.
Yes?
Did we have to show the original function in our answer?
No.
Okay.
It is just one of methods.
Okay, thank you.
You know what, when I show this to my students, I try to make it visual as much as I can, you know what, and this is why I provided that graph of its cousin function, but it is not an obligation. If you like to immediately show just the graph of the given function, it is, if it is correct, it is absolutely perfectly okay with me.
Okay, thank you.
You're welcome. Can I move to the next problem?
Yes.
And here, ladies and gentlemen, I also showed 2 different methods. In number 4, we were asked to prove identity. And look why I'm showing here 2 methods, because I cannot say that one side is much more complicated than the other side. This is why In first method, I'm showing how to prove it starting with left. In the second method, I showed how to prove it starting with the right side. And I'm going to show you right now both methods. Just I used here, starting with the left, I used here simple formula for sine of the difference of two angles using its expansion. And after that, you can see I used algebra. And only at the end, before the last line, I used trigonometry, because each of these fractions, cosine x over sine x, or sine y over cosine y, can be replaced by corresponding trigonometric functions. First fraction can be replaced by cotangent x. Second one can be replaced by tangent y. And this is the end of that proof. Do you have questions about method number one?
No.
No.
So what did we do here in the second method? Starting with the right side, what did I do? I converted cotangent x into cosine x over sine x, and tangent y into sine y over cosine y. Practically, it is first method, but here you are starting with the end and going to the beginning of the method described in method number one. So, and so on. So basically, first line here is just simply replacing cotangent x tangent y by the ratios. And after that, at the second line, it is an algebra, how to multiply two fractions. And after that, how to bring one and that fraction to the same denominator. And on the top, it was the difference of this product, sine x cosine y, and cosine x times sine y, which according to the formula of the sine of difference of two angles can be replaced by sine of x minus y. And this is the second way to prove the same identity. Are you done?
Yes.
So two methods. Definitely, you don't need to show both methods. There are quite easy problems, number 5, 6, 7, and 8. Maybe number 7 has a little bit more steps and it is a little bit more complicated. This why in the weight of all problems, you can see number 5, 6, 8, and even 9, because it is also not really heartbreaking problem. They were just 3 points equivalence. So what should we do here? Perform the indicated operations with complex numbers in algebraic form. And it was the request for numbers 5, 6, 7, and 8. What do we have in number 5? The product of two complex numbers. You just need to simply multiply these parentheses. You could use FOIL, or you could just use so-called one-by-one multiplication. But don't forget that I squared is -1, replace it by -1, take care of that, multiplying by -28, add like terms, and voila, leave your answer in algebraic form, separately showing the real part and imaginary part. Did you do that during the test?
Yes.
Yeah.
Good. Next problem. The second power of that binomial. So definitely, as a first step, you can see I applied the formula a plus b parentheses squared. And when in pre-calculus class, I see that people replace this by 4 plus 9i times another 4 plus 9i, it makes quite bad impression, because everyone in this class needs to know how to apply formula a plus b squared. Definitely, I will not reduce your grade for that, but trust me, it looks quite bad. So same thing, apply that formula, replace I squared by -1, add like terms, and you will get the answer. Can I move to number 7?
Yes.
Yes, please.
Yeah.
This is problem number 7. Here you were asked to, you were, oh, it is so difficult to hold that paper. It wants to. Okay. Can you see the problem? So division of two complex numbers should be performed in algebraic form. What do you do here? First step here, multiply top and the bottom by the conjugate for denominator. In denominator, we had 2 minus 10i. So you can see I multiplied and divided by its conjugate, which is 2 plus 10i. It is a complex conjugate for denominator. Multiply two fractions. On the bottom, you have basically a minus b times a plus b, and I applied difference of two squares formula. This is why I got in denominator 4 minus 100i squared. But on the top, you can FOIL. Don't forget also to replace I squared by -1. This why on the next line here, you can see -2 minus 12i plus 10. On the bottom, you have 4 plus 100. Again, add like terms. You are getting 8 minus 12i over 104. Separate real part from imaginary part and cancel, because 8 over 104 can be replaced by 1 over 13, and 12 over 104, it is 326. And this is your final answer, 113 minus 326 times I. Or I can be in front of 326, up to you. Can I move to the last page?
Yes.
Yeah.
So what do we have in the last page? We have problem number 8. And here we have powers of unit I. I to the, what, 322nd power plus I to the 74. So what do we have to do here? We need to remember that if your power of I has an exponent which is multiple of 4, the answer will be 1. I showed you that formulas, and you can see what I did. I, instead of 322, wrote down 320 plus 2y, because 320 is divisible by 4. Instead of 74, I wrote 72 plus 2. And applied formulas for these powers, I to the 4k plus 2, it is same thing like I squared. And actually both are matching that formula, I to the 4k plus 2. And this why you can even skip, you can even skip that, excuse me, that part, I squared plus I squared. You can move immediately to -1 plus another -1. The answer is -2. So 8, no, do you have questions about 8? Problem number 8?
No.
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 And we move to problem number 9?
Yes.
Yes.
What should we do here? Perform the indicated operations with complex numbers in polar form. Give your answers in algebraic form. We solved quite many of that type of problems. In problem number 9, we were asked to find a square root of a number which was already given in its polar form. This is why there will be not any conversion from one form to another form. But in number 10, originally, complex numbers Z1 and Z2, they were given in their algebraic form. Here we have more steps. I would say probably number 10 is one of challenging problems here. Probably that equation in number 2 in 10 are the most challenging, but 10 probably, number 10 was a little bit more challenging. This is why it has the greatest weight. It is having 5 points equivalent. So let's start with 9. What do we do here? We do not convert this into any other form. You just simply replace that root by the power with exponent 1/2. You have power to the power. You need to keep the base. You are multiplying exponents. This is the end of the usage of the polar form. Now, what did I do here? I converted this into trigonometric form. And having this trigonometric form can be applied as algebraic form, but with strange looking real and imaginary. That's why I used my calculator and converted this, approximating cosine of pi over 12 and sine of pi over 12. And voila, on the last line, you can see your answer in its algebraic form. Can I move to the last problem?
Yes.
Yes.
Okay, this is having much bigger spot here. So I will be showing you line by line. As you can see, first what I did, I converted both numbers into their polar forms. Let me, 1 second, please. I will write right now this in the box. So it will be also quite visual that this is already desired form for these numbers which originally were given in their algebraic form. And again, on this paper, you can see all details of that conversion, including even information about quadrants for each of these numbers. Because when we know the quadrant and we know the tangent value, we can identify its polar angle. Tell me when I need to move that paper a little bit higher, please. I purposely provided here all details.
You can
And
go
again,
ahead.
tell me when I need to raise that paper a little bit.
It's fine now. You can go ahead.
Okay. And you can see after they were converted into polar form, we multiplied them by each other in the polar form, multiplying R1 by R2 and keeping same base E, but adding thetas. After you got this, you are adding that in parentheses, you have two fractions with angles, add them, and you are getting 12 times E to the 13 pi over 6 times I. I will put a star, 1 second, please. I will put a star right here. So this is your answer in the polar form. but we cannot treat this as our final answer because we need to get its algebraic form. And after that, I used Euler's formula to convert this into trigonometric form. And on the third line from the bottom, I simplified 13 pi over 6 because it is 12 pi plus 1 pi over 6. This is how I got 2 pi plus pi over 6 under cosine sine and sine sine. Dropped 2 pi and from cosine and from sine because cosine and sine are 2 pi periodic functions, or if you like, you can use European method to simplify. And finally, on the second line from the bottom, you can see 12 times cosine of pi over 6 plus I sine of pi over 6. Pi over 6 is a reference angle. You need to know values of cosine and sine of this. I replaced cosine of pi over 6 by square root of 3 over 2. Sine of pi over 6 is 1/2. After that, I distributed, and this is why you do not see that 12 in front of parentheses anymore. It is 6 square root of 3 plus 6i. This is your exact answer. If you like to provide your approximated answer, just approximate 6 times square root of 3, which is approximately 10.39. 6i stays not changed. That's it. Oops, excuse me. Do you need this or you are done?
We're done.
I'm done.
Okay. Would you like to ask me about anything or you are satisfied seeing all these details?
I think we're good.
You're good? Okay. So what I am going to do. Now we start actually our last material for this particular class. And this now is chapter number 11. Why did I skip chapter 10? We did not skip that because we already talked about this material before. We talked about different functions like compositions, inverse functions, and etc. Horizontal shifts, vertical shifts, horizontal line test, vertical line test. We already talked a lot in this course about everything. This is why now we are going to talk about chapter 11's material. Definitely, you also talked about polynomials and rational functions, but we will be adding some new point of view, analyzing the behavior of these particular functions. And I'm starting with section 11.1. It starts on page number 432. And the topic is power functions and proportionality. Okay, let me show you what we did last time. This was our review for our quiz. You can see that this problem practically is identical to problem number 10 in your test. So I would like, did you write down the topic? Power functions and proportionality, section 11.1. We do not have a lot of time left to the end of today's our class, but I will just start and definitely I will talk a lot, much more about this material on coming Monday. So I would like to say about right now proportionalities, because you already had some of these proportionalities when you covered material from intermediate algebra course. It was in textbooks for Math 120 course. If you took this course in our college, the name of that course is Intermediate Algebra. Numerical name is Math 120. But what kind of proportionality do we have? You probably heard about so-called direct proportionality. Did you?
No.
Yes.
So can you please first write that topic, direct proportionality? How can they sound? They quite often come in form of a paragraph in the, you know what, verbal form. And it can sound like, let's say, y varies directly as x, or y varies directly as x cubed, or let's say y varies directly as fourth root of x. You just need to carefully read what you have, and after that you need to translate that into mathematical form. In other words, you need to use mathematical modeling. But can you please, let's write it down, because I cannot mention all of these cases if y is proportional to, let's say, directly to x, or to x squared, or to x cubed, or to cube root of x. I will be just using, let's say, x in the first power. Is it okay with you?
Yes, that's fine.
Okay. Can you please write down that sentence? Y is directly proportional to x. And what is the mathematical version of this verbal sentence? In majority of cases, people preferably will immediately write y equals to kx. And people can have quite a reasonable question. Yes, we have here x and y, but what about that k? What is that? Where is it coming from? Yeah, you cannot write y is equal to x, because if y is proportional directly to x, it means it's like a multiple of x. Y can be equal to 1x, it can be equal to 3x, it can be equal to negative 5x, etc., etc. That k which you have here is the so-called coefficient of proportionality. This is a coefficient of proportionality. But not all the time in all textbooks, this is the mathematical model of that direct proportionality. Sometimes you can see this being written in form of proportions. So I'm going to write this in that form as well. x1 over x2 equals y1 over y2, where here two pairs x1 and y1 and x2 and y2, they represent two independent pairs representing that proportionality. This is also directly proportional case. Case of direct proportionality, x1 over x2 equals y1 over y2. I like this form in that proportions better, but even that can be written in different form, and I'm going to write it down as well. Y1 over x1 equals y2 over x2. Y1 over x1 equals y2 over x2. Honestly, I like that shortest form, y equals to kx. I like it more than two others, but I think I need to tell you about all possible forms as I all the time do, because different textbooks can have different forms. And if I showed you just y equal to kx, which I like the best, you can see two others and you can say, oh, our Dr. K never told us about existence of other equations. This is why I show that. Second form, second part, inverse proportionality. Please write it down. Inverse proportionality. What do we have here? Here you can hear this sentence, and I really recommend you to write it down as y varies inversely as x, or you can hear y is inversely proportional to x. Y varies inversely as x. In the first case, it could be y varies directly or directly proportional. This one also has two versions, or varies inversely or inversely proportional to x. What do we need to do? We immediately write this in that form. If you like to, let's say, that form of proportions better, so how can you write it down? I'm going to write it down right now. X1 over X2 equals Y2 over Y1. You can see in case number 1 and case number 2, first ratios are the same. But in the second case, that ratio for Y's is what? A reciprocal of what you had in case number 1, when we had direct proportionality. If you like to write this in the bottom form, in form of proportion, how can we write this in that form? I'm going to write this down. Y1 over X1 equals here. You know what, leave it just in one form, because it will not look really good in that kind of form, because again, I really just do not want to do that, just because it will be more better in just this form. Enough. We definitely can write it down. Or you really like to have this form? Would you?
Yes.
Okay. Do you know the property of proportion when you know what product of means equals to product of extremes? Guys, product of means equals to product of extremes. So, and if you do that in the form of the fraction, so you just need to have diagonals, and product of diagonals will be equal to each other. So basically it will look a little bit complicated. This why I honestly did not want to write it down, but if you like, I will, because it will be a little bit confusing for you. So, and here, what you have here, this is why I do not really recommend you to use that in that form. That first form, which I provided right here, is easier than this one. Definitely, the easiest form is y equal to k over x. Now, third form, joint proportionality. In this case, it can sound like y varies jointly, like, let's say, x, z squared, and t cubed. Absolutely easily. And you can write this sentence like y varies jointly as x and, let's say, z squared. Just write it down. What do we have here? We have the joint proportionality easily, and we usually do not write this in proportional form. K times x times z squared. Y varies jointly as x and z squared, for example. And this is the formula. And finally, the last one. This is, so number 3 was a joint proportionality. This one is having a name of combined proportionality. What is the meaning of combined proportionality? In this case, this sentence will sound as y varies directly as x and inversely as z, let's say. Please write it down as a sentence, and after that, we will write the formula, and it will be the end. Y varies directly as x and inversely as z. Or it can sound as y is directly proportional to x and inversely proportional to z. But this is so-called combined proportionality or combined variation, because we have here both types, and direct proportionality and inverse. What do you have in this case? You are writing this down in that form. Y equals to k times x divided by z. Here you have again the coefficient of proportionality, and you can see here on the top you have k times x because it is directly proportional to x. On the bottom of that ratio you have z because it is inversely proportional to z. Directly proportional to x and inversely proportional to z. Is it clear?
Yeah.
Don't leave, please. I will quickly call your names for attendance, and after that, you are welcome to leave. And as soon as you hear your name, you also can leave. So, and I wish you good weekend. Try to rest. Don't forget about math. I will be posting new homework, but it will be for quite extended period, so don't worry about that. And I think that according to what I remember, that homework will be the last homework for this semester. So today is May the 8th. Andrew, Tima, Lorraine,
Here.
Lynn,
Here.
Juanita, Duran,
Here.
okay, Gabriel, Gabriel, Divina,
Here.
Chantal,
Here.
here, Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Guys, you can leave. I will be ending, and I wish everyone a good weekend. And just a little bit more, I know everyone is tired because our semester will end quite soon. Stay safe and healthy, and have a nice day today as well.
Thank you. Bye-bye.
Bye, guys.